My name's Karen Steele. I'm a Professor of Sensory Function at King's College London, and I run the Genetics of Deafness group since 2012, and we work on a number of different approaches to understand how people lose their hearing. As a child, I think I've always known that I wanted to do research, but I didn't know it was called research. But as soon as I realised that it was possible to work and try to understand better about how the human body works, that was really all I wanted to do. I was very attracted to studying deafness because it had everything. It's got physics, it's got chemistry, it's got biology, it's got genetics and zoology, everything that you have to pull together to understand the process as a whole. I was very fortunate when I started to study for my PhD that I was able to get access to mouse mutants that were deaf. Sometime later, people started talking about the possibility of identifying genes involved in different diseases. And at that point, I decided to apply for funds to identify with Steve Brown some genes involved in deafness in the mouse. It took 7 years to the point where we identified the first gene involved in deafness, which was myosin 7A. Myosin 7A is involved in human deafness. It's involved in Usher syndrome, type 1B. The children are born deaf and with a balance problem, but later on they also develop a retinal problem, and so they go progressively blind as well. And shortly after that, more and more genes were identified involving different forms of deafness. Now we have a vast number of different genes that we know are involved in deafness, getting on for 200 genes in humans. Altogether, me and my group have identified a large number of new mutants, 70 or 80 new genes involved in deafness. For the families, even just having that diagnosis, to know that it's a mutation in a specific gene that is causing their child's deafness, was very important to them, even if there was no treatment available. I've been a great proponent of using the mouse as a model system because the mouse inner ear is so similar to the human inner ear, and the function seems to be very similar at a molecular level. I think my major contribution to the field has been to develop very large numbers of new mouse mutants. In my group, we've studied over 200 different mouse mutants and characterised the hearing impairment in them. The mouse mutants that I've studied over my career are all available to other people to study and continue the initial studies that we've carried out on those. Each of these mouse mutants gives us access to a new molecule involved in hearing loss and is really important to allow us to move forward and develop treatments for more sorts of hearing loss in humans. At the moment, my focus is mainly on progressive hearing loss. Hearing loss in the human population can start at any age. It can start before birth, just after birth, or in the first decade of life, or at any age afterwards. When we get to our 70s, probably over half of the population has some level of hearing impairment. And so understanding the genetics underlying adult onset progressive hearing loss is also very important. In order to develop treatments for adult onset progressive hearing loss, we really need to have better diagnostic tools to understand what mechanisms are involved. We use the mouse because we can understand what's going on inside the ear, but we're developing diagnostic tools that can be transferred to human use. I'm really thrilled to be awarded the Grand Prize. It's a tremendous reflection of the work of my whole team over many years, and it's going to be a great inspiration going forward for our future research. I'm very pleased to be awarded this prize, partly because it means that I can spend more time in France. I can build some collaborations with French scientists working in this field. My dream for the future is that we will be able to develop treatments for many different forms of deafness, not just gene therapy for children with specific forms of genetic deafness, but also for people who have progressive hearing loss as they get older. And that would be a real win for me.